Okay, so I left the Solubility Curves Investigation worksheet as a Word file because that way you can control click the link. Now it's old school, so you need to use, you need to use Explorer or Firefox. So this video is for those of you that don't have those or can't get it to work on your computer. You get to watch me do it. Okay, so in the intro video we talked about what we're going to do. We're going to test these solids and we're going to test them at different temperatures, and you're going to produce a solubility curve, and hopefully you will visualize the trend. These are all solids. You can see they're white powders, that when you increase the temperature there should be more dissolving. So if you're going to do this on your own, start with the highest one. Okay, that gives too much, so you click undo. Saturated solutions do not show precipitates. That is over the saturation point. So then you just have to keep adding smaller and smaller increments. Okay, so undo that. So NH4Cl at 0 degrees Celsius is 30 grams. So now we are going to switch temperatures. Now you can even see the hot plate started to light up. Again, so now you can theorize to yourself when you're doing this, should it be greater than 30? Yes, because these are solids. And when you increase the temperature, the amount you dissolve should be greater. So again, start with the biggest. Still too much. Let's try this. Too much. Okay, so 20 degrees Celsius is 38 grams. Up to 60. Again, now we should get more than 38, right? So again, go back to the highest amount you can add. Oh, quite a bit of an increase here already. Okay, so that's 56 grams. And now up to 100. Too much. Okay, so 78 grams. Okay, so now barium hydroxide, go back to 0. Actually, it doesn't matter, but I'll go in the same order. Start with the highest amount. Oh, whoa, already too much. Let's try 10. Already too much. So only 3 grams. Okay, let's up the temperature. I would imagine it's not going to jump to 25. Nope, but let's give it a try here. Oh, not even 10. but it should be more than 3, right? Not much more, but more. So we got to 5. Let's go to 60. Now really, I did not expect that to work. 10, we're good. 12. 13. 22 grams. Okay, so up to 100. Oh, 25 worked. Oh, even 35. Oh, 45. 55, 65. So 102 is where barium hydroxide maxed out. Okay, let's do copper sulfate, back to 0. Start with 25. Too much. Start with 10. Let's see, about 20. Oh, yeah. Gotta be 24. Oh, 23. Or 24. Yes. 24 for CuSO4 at 0. Okay, let's up it to 20 degrees. So when you're doing problems related to solubility curves, you always want to make sure you're cognizant of the units. So temperature goes on the x-axis, solubility goes on the y-axis, but some of the numbers will be really close together. So putting the little degrees Celsius sign will be important, including the grams per milliliter is important, that kind of thing. Okay, so that's 33, and you can see here it's grams per 100 milliliters of water. Okay, so 33 for 20. It's up to 60. So let's try 50 here. Let's see what we get. Oh, we're good. 75? Nope. is 62 grams. And then 100. We can get up past 62. Try 75. Oh yeah. Good to go. Oh, too much. So we got to 115 grams per 100 milliliters at 100 degrees Celsius. So this seems strange. How can it be greater than the amount of water? Well, once you get really hot, then you are forcing it to dissolve more than you would expect, which is indicative of a supersaturated solution. Okay, KCl, let's go back to 0. We'll try 25. Potassium chloride is one of the ingredients that can be injected and stop a person's heart, so not to be trifled with. (29 grams), so not bad at 0 degrees Celsius. And then when we get to 20, it's going to be higher than 29, but not 50. So let's see what we get here. 35. 35 grams, right on. Now up to 60, so higher than 35. Let's try 50 right off the bat. No good. Okay, so 47 grams. And now up to 100. So higher than 47. But maybe not much higher. So 57 grams for KCl at 100 degrees Celsius. Okay, and on to sodium nitrate. So nitrates and sodium, any alkali metal, are generally speaking pretty soluble. So starting at the top, whoa, already at 50, even at 0 degrees. There we go. Too much. Okay, so 74 at 0 degrees. So let's try 75. 100. 100 too much. $89. Up to 60 degrees now, so past 89 for sure. Let's see, can we get to 100? Yes, we can. Oh, too much. 110. 120. Oops. Sorry, click the wrong one. 120. 121. 122. 123. Must be 124. Oh, nope, 123. Okay, so 123 at 60 degrees, then 100 degrees Celsius. So let's get past 123. 125, 150. Oh yes. 175. Oh, 200 too much. Okay, 181 grams for sodium nitrate at 100 degrees Celsius. So remember, when you're building your solubility curve, the temperatures go on the x-axis, so you'll have the same temperature values for all the solids, and then the solubility, which is grams per 100 milliliters of water, they will be different. Make sure that you somehow label your lines. So if you want to upload that, if you choose to do it on Excel and you want to upload that file, that's fine. Or for the curve part, and then answer the other questions on the worksheet. Or if you want to label the lines at the end of the line, you can, if you have a scanner app that doesn't do color, or you can use color with a legend. Like if you use the Notes app, if you have an iPhone, then it should scan in color, no problem. Okay, otherwise, take a picture, send it to me, whatever. Just make sure your curve has a legend. And when you go to answer the questions, the legend will be important as well. Okay, and this is going to serve as your assignment up to this point. So the next assignment for this unit will start with the next lesson, which is concentrations, calculating concentrations. Okay, thank you.